Hello. My plan for this video was to find the derivative of the function sine of x, so f of x is equal to sine of x, using only the definition of a derivative. So if you recall, the definition of the derivative is that f prime of x, the derivative, is equal to the first part is very important, the limit as delta x goes to 0 of f of x plus delta x. I got a little bit too excited to write f of x plus delta x minus f of x divided by delta x. So using this definition only, and no tricky rules or anything except for perhaps one, we are going to find f prime of x. So let's just plug things in. We know that since f of x is sine of x, f prime of x is going to be equal to the limit as delta x goes to 0 of the sine of x plus delta x minus the sine of x divided by delta x. And there are ways to simplify this further, of course, and that's what we're going to be doing. So if you remember from our trigonometry videos, there is a way to separate this out, sine of x plus delta x. It's the angle addition identities for trigonometry, and that's what I'm going to be using to expand this right now. So when expanding this to kind of get rid of the x plus delta x in there, what I'm going to do is write this out as the limit as delta x goes to 0 of sine of x times the cosine of delta x plus the sine of delta x times the cosine of x minus the sine of x divided by delta x. This is what you can find using the rule, this expression right here. If you forget it, that's a good thing to know, but I'm just telling you right now, the sine of x plus delta x is sine of x cosine delta x plus sine of delta x cosine of x. That's just the angle addition identity. So now, what can I do? Well, I've got the sine of x here, the sine of x here, so maybe what I'll do is say that this is the limit as delta x goes to 0 of sine of x times cosine delta x minus 1 plus sine of delta x times cosine of x. You'll notice all that I did here, all that I did to make that happen is I moved this over here, which you're perfectly allowed to do, and then I reverse distributed sine of x. So you'll notice if I distribute this out, I get sine of x cosine of x right here, sine of x cosine delta x minus sine of x over here, and then I still have this expression here. So let's keep going if you're comfortable with that. And this is divided by delta x, of course. And we're going to have to probably erase some things to finish this, but there are more things that we can do. For one, I'm going to separate this out into the limit as delta x goes to 0 of negative sine of x times 1 minus cosine delta x. All that I did is I multiplied by negative 1 twice. You'll notice when I multiply by negative 1 in here, this turns into this, so I multiplied by a negative here to cancel that out. So these are still equivalent. And then we're adding sine of delta x times the cosine of x divided by delta x. Now I'm going to use, what should I do? Well, now that I have two terms like this, I'm going to use one of the limit rules and rewrite this this is going to be equivalent to the limit as delta x goes to 0. And this isn't necessarily like a really important step, but I'm going to do it anyway just for clarity. That this is going to be the limit as delta x goes to 0 of sine of x times 1 minus cosine of x, cosine of delta x divided by delta x, plus the limit as delta x goes to 0 of sine of delta x times cosine of x divided by delta x. And we're going to have to clear some space now, so I'm going to do that at the top. Hopefully you're familiar with all this stuff, so I'm going to leave the f of x, but all this other stuff I'm going to erase, just so that we have some room. And hopefully you see what I did there on that last step. All I did is separate it out into two limits, because we know from what we learned about limits that that is an operation that can be done that leaves them equivalent. All right, and let's switch to another color even. So now that we have this, let's bring this all up here. I'm going to maybe even bar this off. We might have to do this multiple times. So this is going to be equal to, what else can we do? Well, I'm going to do something interesting. I'm going to say that this is equal to the limit as delta x goes to 0 of negative sine of x times 1 minus cosine of delta x times 1 plus cosine of delta x divided by delta x times 1 plus cosine of delta x. You'll notice I just multiplied the top and the bottom by 1 plus cosine of delta x. So these would normally cancel out, but they will do something special that I think is going to be more helpful than if we just canceled them out. And then we're adding this to the limit as delta x goes to 0 of sine of delta x cosine of x divided by delta x. Okay, so what now? What can we do now? Well, let's see. What happens when we do 1 minus cosine of delta x times 1 plus cosine of delta x? Well, we know from algebra that this is going to be the same as the limit as delta x goes to 0. And I really did just separate these out just so that we could look at them separately so that things didn't get too jumbled. So this is going to be the limit as delta x goes to 0 of negative sine of x times, we know from algebra that these here will multiply out to be 1 minus cosine squared of delta x divided by delta x times 1 plus cosine of delta x. And then we're adding the limit as delta x goes to 0 of sine of delta x cosine of x divided by delta x. Okay, so what's important about, why did we turn this, which we had up here, into this? Well, if you're familiar with trigonometry, you'll know that this expression here is equivalent to the sine squared of delta x. So this is going to be all equal to the limit as delta x goes to 0 of negative sine of x times sine squared of delta x divided by delta x times 1 plus cosine of delta x. And we're almost there. We're so close. And then we're adding the limit as delta x goes to 0 of sine of delta x cosine of x divided by delta x. Okay, and this is not really a great delta. Now I'm just going to write this a tiny bit differently. I'm just going to change things around a tiny little bit. I'm just going to say that this is, and perfectly fairly, this is the same as the limit as delta x goes to 0 of, well, what's this going to be? I'm going to say that this is equal to sine squared of delta x. Actually, even better, let's just say that this is limit as delta x goes to 0 of sine of delta x divided by delta x times the negative sine of x times the sine of delta x. This might be looking a little bit strange, divided by 1 plus cosine of delta x. So all we've done, these are still together, we've just separated this term out here from the rest of it, and that's going to be important in a moment. Now we're adding the limit as delta x goes to 0 of sine of delta x over delta x times the cosine of x. And now I'm going to erase a bunch of this stuff, including, let's erase that last part that we had from the last section. Let's just erase this for now. And I'm going to erase this stuff up here because there's something new I want to write up here that will bring a new light to the problem, I think. And this is something that I'm not going to derive in this video. This is that one kind of tricky trick that I alluded to at the beginning of the video. The one kind of trick that we'll be using that isn't kind of familiar already, perhaps, and that's going to be that the limit as x goes to 0 of the function sine of x, just where x is some variable, it could be delta x, it could be anything, if sine of x divided by x is equal to 1. And hey, wait a minute, look, we've got a thing that looks a lot like that here and here. Isn't that fascinating? So, what's our next step going to be? Well, I'm going to use the rules that we've learned about limits to separate this out one more time. I'm going to say that this is going to be equal to, right, when we have the limit of one thing times another thing, that's the same as a multiplication of the limits of those two things. So this is going to be equal to the limit as delta x goes to 0 of sine of delta x over delta x times the limit as delta x goes to 0, and I might run out of space here, in fact I probably will, of, what do we have here, negative sine of x times the sine of delta x over 1 plus cosine of delta x. Oops. And you'll notice that we haven't been solving this yet, because anytime we plug in 0 for delta x, when we're kind of trying to see what the limit is, all we get is this thing where we get 0 on the top and 0 on the bottom, which is ambiguous. It's indeterminate, and it's not something that we can work with. And now we're adding, I might actually have space. Let's see. We're adding the limit as delta x goes to 0 of sine of delta x over delta x times, oh no, I'm not going to have space, oh well, times, this is being multiplied, times the limit, well actually here's, yeah, we might as well do this, limit as delta x goes to 0 of cosine of x. Okay, and I'm gonna remove some of the stuff that we wrote up here at the top so that we can bring this home to our final answer. So let's just get rid of this. Hopefully you've been either taking notes or you remember what we did. So, all of this, we can start essentially plugging in values. So, I'm just going to bring this up here so that we can perhaps see it a little bit better. But let's get rid of the things that don't mean anything yet. Well, actually, let's see. Yeah, so if we look at this second term here, if we look at this one here, look, 1 over cosine of delta x, well, when delta x goes to 0, that's 1 plus 1, so this is the same as 2 down here. And negative sine of x times sine of delta x, well, as delta x goes to 0, this goes to 0, so this whole thing turns out being 0 divided by 2, or 0. So this will cancel out to be just 0. And is that okay, right? Because look at this, if we're dividing 0 by 0, then we might have issues there. So what is this going to be? Well, look back up here. The limit as some variable goes to 0 of sine of that variable divided by that variable is equal to 1. So this thing is just going to turn into 1. And I'm actually going to I feel bad about that arrow being there, but this thing is going to turn into 1. So we have 1 times 0 plus, what's this going to be? Let's do this up here. So we have 1 times 0 divided by 2 plus, well, we have the limit as delta x goes to 0 of sine of delta x over delta x. We have the same thing, so this is also going to turn into 1. So we have plus 1 times, well, now we have the limit of cosine of x as delta x goes to 0. I'm actually going to write that up here, just because this is our final part, and I wrote it kind of messily down there, of cosine of x. Well, notice, delta x isn't in this expression, so the limit of cosine of x as delta x goes to 0, delta x isn't even involved. It doesn't matter if delta x goes to 0. This is just going to be cosine of x. So our final answer, in final form, this cancels out just to 0. We are going to get, and this is just 1, so 1 times cosine of x. We know that f prime of x, given all these steps, is going to be equal to the cosine of x. And if you've seen my useful derivatives video, you'll know that this relationship is true. But I thought that it would be interesting to do a video showing exactly how you can, just based on the definition of derivatives, find this definition, doing all these steps, and we erased all these steps, but we finally gotten to the answer. F prime of x is equal to cosine of x, and all you need to do is recognize that the limit as x goes to 0 of sine of x over x is equal to 1, and recall some of your trigonometric identities. I hope that this wasn't too messy. Looking at the screen right now, perhaps that's not the most hopeful thing, but I do hope that at least to some degree this did help with your understanding of derivatives, and kind of as a proofy type thing for a derivative that we will be using very often in the future. Thanks for watching.